Our next lectures are going to finish off our unit on trigonometry. So far we've done a lot with regards to the basics of trigonometry, like SOHCAHTOA. We've done the unit circle. We've solved trig equations. We've graphed sine, cosine, all those trig functions. And so the last thing that we really need to talk about is what happens when we have triangles that don't have right angles. So what we call non-right angled triangles. So you probably noticed the whole unit, we've pretty much been talking about triangles with right angles already in them. Even when you think of the unit circle, which was about half of our unit, everything, even if we had a piece of the circle, we would go to that piece and then we would make a right triangle with it. So this last part is really asking, what do we do when there isn't a right angle at all? So I want to introduce you to a little bit of naming convention. So when we have any triangle really, but specifically these non-right triangles, we still need a way to refer to the sides and the angles that we're using in our calculations. So pretty much the rule of thumb is whenever you have a capital letter, so I'll refer to it right here. So letters that are capital refer to angles. And letters that are lowercase, I'll put LC for lowercase, those are sides of the triangle. Okay, so just internalize that. If you see capital letters, think of angles. If you see lowercase letters, think sides. So I'm going to put these on my triangle. So this is just random. So I'm calling that capital A. And the side directly across from that capital A, we tend to call lowercase a. Same thing if we did capital B. The side across from it, we would call lowercase b. And then same thing if we did capital C, side across from it, we would call lowercase c. So just be very careful when you're writing your letters to make sure you're writing capitals for angles and lowercase for sides. Okay, so now we're ready to figure out some of the relationships in here. Okay, so up to now, like I said, we've only really been focusing on right triangles. So that's really all we know. So let me go ahead and draw a little line here. Actually, I don't like that line. I'm going to draw another line. I'm just going to make it like that. Okay, so notice that I drew this line in the triangle. We call this a few names. So some of you probably have heard of this referred to as the height of the triangle. You could also refer to this as the altitude of the triangle, either one. Okay, so we have either height or altitude. So that's this line right here. Right there. And notice that the altitude does something very special. Even if the triangle is not a right triangle, it splits it into two right triangles. So you'll notice that there's the triangle right here on the left-hand side. It's this kind of skinnier triangle. And then you'll notice there is another one over here on the right-hand side. This one's a little bit bigger. Okay, so for the purposes of this derivation, I'm going to draw them separate. So I'm going to draw the so that's going to be the skinnier triangle on the right, and this one's going to be the other triangle on the left. Okay, so if I look at what I know so far, let me color code it. So this is the triangle on the left-hand side. Oops. And this is the triangle on the right-hand side. Okay, so let's go back to our letters right here. So if I look at the pinkish triangle, I can see I can see that I know this angle down here in the bottom corner. That's capital A. I also know this right here on the side is lowercase b. I can't really mark C because notice that the angle kind of got chopped, so I can't really name that. I don't know the full length of the base down here, so I can't name that. But since I introduced this length right here, I'm going to call that H for height, and I'm going to make that a part of the triangle. And then same over here, I can call this H. Down here in the bottom right, I can call this capital B, and I can call this one over here lowercase a. Okay, now this is called, the first one that we're doing is called the law of sines. So it shouldn't be a secret that we're probably going to need to figure out a sine ratio. So right now this is the only angle that we have. Remember that we call that a reference angle. And that's going to help us label our hypotenuse, opposite, adjacent. So across from the right angle, oops, that's not what I wanted. So across from the right angle, we call that the hypotenuse. Across from the reference angle, we call that the opposite. And then we call this one down here adjacent, but we don't really know anything about it. So we have opposite adjacent, which is very clearly a sine ratio. Okay, so I'm going to go ahead and say the sine of angle A is equal to opposite over hypotenuse. And if we do a quick little cross multiplication, we can get another relationship. Another way to say height is lowercase b times sine of capital A. Okay, so very important relationship. I'm going to highlight that because we're going to need to come back to that in a second. Okay, relationship 1. Now let's look at the green triangle. So in the green triangle, this is going to be the reference angle because that's the only angle that we really know. And again, it's going to help us label our adjacent, our opposite, and our hypotenuse. So across from the right angle, that would be hypotenuse. Across from the angle will be the opposite. And again, we're in the same boat. This would be the adjacent, but we don't really know anything about it. So we can also say sine of capital B is opposite over adjacent. And again, if we cross multiply, that would give us H is also equal to A times sine B. Okay, so we have some interesting relationships here. Now, the trick with all these non-right triangle equations or formulas is that we always want to express our formula only using the sides of the triangle or the angles. So I only want little capital A, capital B, capital C, or lowercase b, lowercase a, lowercase c in my formula. Right now I have H, and that's not really helping because you won't always have the height of the triangle labeled, and you may have to do a lot of additional work to figure it out. But if you notice, there's actually a very simple substitution we can do. So if you notice, we have the same variable, height. We have two different ways to express the height. And so one of them is equivalent to lowercase b sine of capital A, and the other one is equivalent to lowercase a sine of capital B. So we can just say these are equal to each other. And ta-da, now we pretty much have a formula for one of the relationships in non-right triangles. Now I will make one suggestion. So normally when you look in textbooks, you won't see it written this way. They kind of made it a little bit easier by dividing for you. And the reason you would do that is because now these B's can cancel, these A's can cancel. So it's a little bit nicer to remember. So you have sine of capital A over little a, and sine of capital B over little b. And that's really the main one that I want you to remember. So here's one of the good thing about this is there's really only two major formulas in this last part of the unit. You just have to know when to use them and how to use them. So that's one of them. And then I was going to, if we were in class, I would use this this other triangle to derive it another way, but I think you got the idea with that first one. So there's actually another way because you also have a third angle and a third side. So this is the law of sines. It pretty much says this relationship is true for non-right triangles. So that's the one that we just did, and I'm going to tag on very similar fraction for lowercase c and capital C. So this is the law of sines. Okay, it comes kind of in three flavors. You really will only really use two of the flavors at a time. Just remember that capital A, capital B, capital C, those refer to angles of the triangle. And lowercase a, lowercase b, lowercase c refer to sides of the triangle. Okay, so this is the formula. We will be using it quite a bit over the next week or two. And in another video, I will show you how to use the law.